we do that here now, then we'll have the following. See, 18 will be 2 times 3 squared to the power y, multiplied by 8 will be 2 cubed. So it'll be 2 cubed to the power y minus 1. Right, so now we're done. We've done the converting step. Now let's do the distribution, because we're trying to simplify, right? We have brackets in the way. Brackets organize things. We need to open everything out so that we can see what we would not otherwise see. Right, so this is why we need to open these brackets out. So how we're going to do that is distribute here. So if we do that, we'll get the following. It'll be 2 to the power 4y. 2 times minus 1 is minus 2, multiplied by 3 to the power 2y plus 2 over. See, we're still under the distribution step. We did that part. Right, it'll be 2 to the power y multiplied by 3 to the power 2y multiplied by 2 to the power 3y minus 3. Right, so hope everyone's following so far. Then we separate. What does a separation step mean? We're making use of the exponential law. You see, when we did exponents, we said if we had a to the power of m multiplied by a to the power of n, then this is the same as a to the power m plus n. Right? Stated verbally, whenever multiplying terms with the same base, keep the base and add the indices. Now, if you look at this here, the indices are already added or subtracted, so we need to go to this this form, right? And so this is the powerful part about maths. We have what we call converses, and so it's like this here. It goes like this here. If this, then you do this. Can you see that? If I see this, then I can do that. But the converse is, if I see this, then I can do this. Now, the important thing is, it doesn't always apply in maths. So your teachers need to tell you when these rules are applicable. Because when you get to university, it doesn't always go in the reverse direction. This is why they'll use the statement if and only if, right? If and only if. You'll hear it again. So yeah, so going in the forward direction, we can also go in the reverse direction. And so now what we need to do is, we need to go in the reverse direction for the purpose of separating. And so if we do that, we'll have 2 to the power 4y multiplied by 2 to the power minus 2. Whenever multiplying terms with the same base, add the indices. So we did not change the question, we re-expressed it for the reason I will mention just now. This will be 3 to the power 2y multiplied by 3 squared over 2 to the power y multiplied by 3 to the power 2y multiplied by 2 to the power 3y multiplied by 2 to the power minus 3. So why did we do this separation step? We know why we did the converting step, because everything has to be in prime basis. We know why we did the distribution step, because we need to get rid of the brackets. So why did we do the separation step? We did it for this reason. We're trying to separate variable exponents from numerical exponents. So we're trying to separate variable exponents from numerical exponents. And so if we do that, if I highlight it, can you see now? I can do this. See, that's a variable exponent. Variable exponent there. There's a variable exponent here. See here as well. Variable exponents. This here. Numerical exponent. And that there will just stay on its own. This one here will stay on its own. And so if we simplify now, can you see why? We do this because the exponential rules, listen to this, the exponential rules will only enable us to simplify if the bases are the same and if the indices, the exponents are of the same nature. Because think about it, if you have a variable and a numerical exponent, it's going to come back to this form. There's no point keeping it like that. So that's why we separate it, work with variable exponents. See, work with variable exponents, right? And then work with the numerical exponents, provided that the bases are the same. That's why we learn the exponential laws. And so if we do this, can you see here? 2 to the power y multiplied by 2 to the power 3y gives you 2 to the power 4y. 2 to the power 4y over 2 to the power 4y is 1. All of that will cancel. 3 to the power 2y over 3 to the power 2y, that will cancel, right? Can you see what we're doing now? We're at the simplify step. We're making use of exponential laws. Here, this will be top minus bottom, isn't it? So it'll be 2 to the power minus 2 minus minus 3. Can you see that? Very important. Keep the brackets. Multiplied by 3 to the power 2. And if we simplify this, we'll have minus 2 minus minus 3 will give you minus 2 plus 3, which is 1. So it'll be 2 multiplied by 3 squared with 18. And so when you're given these questions, it's just a useful way of thinking of it, which I don't like. But 99% of the time, it should come down to a number answer. If you're not getting a number answer, you're doing something wrong. Right? So if you had something like 18 multiplied by 2 to the power y. So if you have a variable exponent, you're doing something wrong. There's a 99% chance that you're doing something wrong. Okay, so can you see that? I'll do a side by side here now, right? I'll do a side by side. So this is when you have an exponential expression involving only multiplication and division. We first did the converting to prime bases. We then did the distributing because we need to get rid of brackets. We then did the separation using law 1 because we're trying to separate variable exponents from numerical exponents. Because if they are together, then this is what we get. This here, we can't simplify. As it is, we can't. So this is why we do the separation. And then we did the simplifying step because that was the whole point of maths. It's trying to simplify something like this down to that. Okay, if you're thinking about deep enough, see even this here too. This here, this is what? A fraction, isn't it? If it's a fraction, the denominator cannot be 0. Can you see that? But we won't go so in depth. But because these are exponential expressions, then it's very unlikely that they'll be negative, right? But that's a bit of a higher order way of thinking of it. But you can see, you could do this here. Put this into a graphing calculator and see where the value where it'll become negative. Right? That's just a bit of a insight into some deeper stuff there. Right, so now we got this here. We did this part here. Right, so if you look at this here, if you're following so far, we did all of this here. Right, and we follow the rules. Now let's do this here now. This part. Remember, we're learning frameworks, we're not learning questions. Right, if we do this part, where's this question? So it'll be 2 to the power 2n plus 2. To the power 2n plus 2. 2 to the power 2n plus 2 minus 2 to the power 2n plus 1. Minus 2 to the power 2n plus 1. Yeah, so right, let's go over this now. We're dealing with an exponential expression that involves plus and minus signs. There I can see a minus sign there, so we have a plus and minus sign here. So what do we need to do? First step for any exponential question is convert to prime bases. And so if I do that, this is what I'll get. That's already in a prime base. That's already in a prime base. We need to sort this out. So this will be 2 to the power 2n plus 2 minus 2 to the power 2n plus 1 over 2 to the power 2 to the power n plus 1. Now we need to remove the brackets by distributing. I can't distribute here, I can't distribute here, I can here. So if I do that, I'll have this here. 2 to the power 2n plus 1 over 2 to the power 2n plus 2. Right? We did the distribution step. Now we need to do the separation step. What do we use? We use this here. So if we do that, we'll have 2 to the power 2n multiplied by 2 to the power 2 minus 2 to the power 2n multiplied by 2 to the power 1 over 2 to the power 2n multiplied by 2 to the power 2. Okay, guys, I'm going to end the meeting. Log back in, please. Thank you.